In this video, we're going to perform blindfolded testing for our outdoor navigation application. In this test, we're going to use Google Directions API and Google Maps API to grab GPS input and update the directions in real time. The Google GPS service will notify the internal network when we arrive at waypoint and update the instruction for the next movement. There are 4 possible instructions: forward, left, right, and arrive. The neural network inside the application, called the developmental network, learns supervised action, the current GPS input, the recognized object, and supervised attention, and then associate these concepts with the current visual input. The network learns online in real time with no need to store a large amount of training data. Online training and testing with simulated GPS is shown in previous videos. There are 2 major differences of this test compared to tests performed in previous videos. Firstly, we're using a real GPS from Google API rather than a simulated GPS with human supervision. The application constantly updates the location and calculates distance from the next waypoint. Secondly, I'm completely blindfolded after we have finished the initial setup. A GoPro camera is mounted at the level of my nose to film the screen of the phone. I'm going to be completely reliant on the audio output from this phone to navigate to the destination. My friend Janelle is standing away from me to film my movement and make sure that I do not step into bushes and get hurt. Now see me do some of the setups for this testing. I press Settings, select Real-Time Testing Mode, enable Sound, and then press Load Network. In this video, we're going to load a pre-trained network. Then we go back, press GPS, and get a map from the Google Directions API. Here we can select our destination and get the steps and maneuvers using the Google Directions API. Press return and we're ready to go. Now I press go and put down the blindfold. I am now deprived of any visual input and is totally reliant on the audio output from the application to navigate. As you can see, overcasted shadow caused some inconsistent performance, but the network eventually led me to the correct path. As is shown in this section of testing, the network is able to correct my phasing direction and follow the GPS output. We're going to make a right turn at this intersection. Because we have already set up the GPS, the application would change the GPS information to turn to right when we are within 5 meters of that intersection. Now the network is asking me to turn right at the intersection. It also reminds me to turn slightly left when we are overturned to the right-hand direction. After we walked away from the intersection, the GPS is changed back to forward. The network reminds me to return to the middle of the road. Here the network asks me to turn right again at this intersection. The network successfully sees that I'm about to step off-road, but I was following the previous instruction and did not wait long enough. I step off-road, which is really scary given that I cannot see what happened and had to return to the previous position. Again, this arrow is on my side because of my hasty movement. The network did not have enough time to remind me that I'm about to step off-road. Everything is now back to normal, and now we move on to the next part of the experiment. Now I arrive at the destination successfully. The GPS had changed to arrive, and the network tells me to stop. This is our destination, and we finish the testing here.